Welcome to Soil Science and Management, Chapter 10. And in this section, we're going to discuss soil fertility. So the objectives here are to name and classify the essential elements that are required within the soil to grow plants, 4 sources of nutrients within the soil, describe what soil colloids are, define cation exchange capacity and some terms that are related to that, describe how plants absorb nutrients, and then some other soil fertility factors. So soil fertility is basically the ability of soil to supply nutrients for plant growth. This has to do with the quantity of nutrients, um, how they move within the soil, how available they are. If you recall, we've talked in the past about pH and how pH affects soil and the quantities of the nutrients within, and this is a very important part of soil fertility. So there are several plant nutrients that are considered essential elements. Um, they fall into 3 basic categories. Those are the primary macronutrients, the secondary macronutrients, and then micronutrients. There are approximately 90 elements that can be absorbed by plants, but only about 16 that are useful to plants. So some of these plants are detrimental to plants and can cause toxicity, and others are involved in the perpetuation of plants and will be something that the plants can utilize to grow stronger. So the the macronutrients that we commonly know are the primary ones are nitrogen, phosphorus, and potassium. These are the ones used in the most uh, highest concentrations, often referred to as NPK, will be associated with the numbers on your fertilizer bag. These all have varying functions within the soil within the plant. Nitrogen is encouraged to have top growth on a plant. Phosphorus encourages root growth, and phosphorus and potassium together encourage fruiting of a plant. Then we come into the secondary macronutrients. Those would be considered your calcium, your magnesium, and your sulfur. These are considered secondary because they are still needed in a high concentration, but not nearly as high as your primary. Oftentimes, if you see a 4th number upon your fertilizer bag, it will be sulfur or calcium, and these can be also given out in percentages based on the numbers that are found upon your fertilizer bag. Next, we come into micronutrients, and these include boron, copper, chlorine, iron, manganese, molybdenum, nickel, and zinc. These elements, some are used in such very little concentrations that you would never apply them to the soil. So, for example, boron and chlorine are almost never applied to the soil because they are needed in such minuscule amounts that just about everywhere that can be found. The amount of chlorine that is in your residual water supply is sufficient enough to supply enough chlorine to the plants that you don't need to add it. And boron is one of those kind of funny ones. If you it is a plant essential nutrient, but if applied in too high of a concentration, can actually be a detriment to the plants. There's a place called Boron, California. If you're ever driving through, it's in the kind of middle of the Mojave Desert, and there is such a high concentration of boron that there aren't very many plants that grow in that area due to this higher concentration because the soil has become toxic to those plants. Many of these other elements are metals. They are the essential metals that need to be used by these plants, and oftentimes these are put out in chelated form or coated form so that they are slower release, so that they're always present in the soil. Uh, there are a couple of beneficial elements, and these are sodium, silicon, and cobalt, not as readily needed within the soil, but they are beneficial to the plants and to the soil. Um, as we continue to talk about plant nutrients, there are nutrient ions, and an ion is basically a charged atom or molecule, and a positive ion is called a cation. A negative ion is called an anion. These are both absorbed by plants through the roots, and they can also be absorbed or attached onto soil particles. And we will shortly be talking about the cation exchange capacity of a soil. So basically, there are four pools of elements within the soil where they can be found. So you have your soil minerals, you have your organic matters, you have absorbed nutrients, and you have dissolved ions. These are the four main areas that can harbor these elements within the soil. The mineral pool is basically your primary soil minerals. Um, and these are going to be like where these soil elements can come from. They're broken down from other uh, larger forms and broken into smaller microscopic forms that can be then utilized in the soil. Um, this mineral pool is more or less the weathering of the soil into these smaller particles. You also have dissolution, which is basically when the soil is dissolved into a solution where these elements are able to permeate through the soil through this dissolution. Um, Soil colloids are basically um, clumps of particles that contain nutrients or uh, electrical charges that can latch onto these nutrients. So you have these tiny clay and humus particles, and humus is basically a broken down organic material to a almost liquid organic material. There are three different types of these colloids. You have silicate clays, you have oxidized clays, and you have humus. So the clays that the different types of clays are shown here. Don't really need to read them all, but basically these are all going to contribute to the amount of nutrients that can be held within the soil. And getting right into here, the cation exchange capacity, also known as the CEC, is very important in how to prevent leaching of nutrients out of the soil. So these soil colloids that are within the soil can be very useful in the fact that they become electrostatically charged, and they will hold on to these cations. So all of these soil particles are negatively charged, so it will find the positively charged ions and grab onto them and hold them in place so that they can be found and utilized by plants. And this exchange is one molecule or one element being exchanged for another across the spectrum. So for example, calcium and sodium are very reactive together, or potassium and calcium are also very reactive together, and they can exchange themselves um, within this soil medium and allow different aspects of soil to be used in different areas. So, like I said before, the cation exchange capacity is the ability for soil to hold a nutrient, and this is determined by the amount of clay, the type of clay, and how much humus is within the soil. Um, we're not going to do a ton of work with this, but it is measured in centimoles per kilogram, within the dry soil. And this is something that is fairly advanced in the soil science department, but understanding that this is how these nutrients are moved within the soil is very important to understand. So anion storage is also an exchange process, and these anion exchanges, they store small amounts of these anions, but they are going to be the opposite of the cation exchanges. So there are some nutrients within the, or excuse me, particles within the soil that will hold on to these anions in a very similar way to the cations. Now, that is prevalently known because most of the elements that plants utilize are cations, and that is one of the things that you need to consider when you are looking at nutrients and how this cation exchange capacity works. Is there are more cation nutrients than there are anion nutrients. So you can actually up or you can manipulate your CEC by adding in different particles, and then you can utilize this increased CEC for influencing your fertilization practice. Once you understand that this cation exchange capacity is how these nutrients are moved, in performing soil tests and soil sampling, you can determine how high your CEC is, and then you can apply fertilizer to be utilized efficiently by those plants over a long-term basis. Okay, nutrient uptake is done very similarly to water uptake within a plant, and this is all done through osmosis. So you have root interception. That's where roots grow into the soil area that contains the nutrients. Then you have something called mass flow, and these nutrients are carried to the roots by water flowing toward them. So this is almost a magnetic reaction where the water flows or is carried towards the roots. And then diffusion is where the ions are driven through the soil water by a gradient towards roots. And this is basically where those particles can be taken by water and bounced off of different particles and driven toward the root system. So things that affect uptake is going to be your oxygen supply. Again, if a plant can't breathe, a plant can't live, and if there's no open pore space within the soil, that is not a happy plant, and it's not going to be able to take those nutrients into it and allow it to be utilized. Water supply has to do with if there's no water, then the nutrients can't move within the plant. All nutrients have to be within the water to be moved into the plant. A plant can't take a solid form of a material and break it down and uptake it into its root system. It has to be done using water in that system. And then soil temperature affects uptake. Obviously, the warmer it is to an extent, the better the uptake will happen. One thing that's not included here on the screen, but I spoke about it earlier in the beginning of this, is pH. And pH has to do with availability of these nutrients. And when you are higher or lower than the 7 standard pH, you start to have unavailable nutrients and elements, and this can be a great effect on the uptake of these nutrients. So we talked about the 16, 17 essential nutrients that are used to grow, how they're absorbed from the soil, the nutrients that exist in the soil minerals and organic matter. We talked about soil colloids and how important they are. And we talked about how those nutrients enter the plants and how the the plant can utilize those nutrients. Thank you for joining me again, and we'll see you next time.